In the last section, we talked a lot about passing functions as arguments to other functions with the expectation that the outer function will call your argument function, which we call a callback. And I said, I'm showing this to you because callbacks are central to JavaScript. In fact, tons of built-in methods expect you to pass a callback function. So in this section, we'll see some of those methods, some of the most useful built-in methods that expect you to pass a function in. And these all have to do with arrays. That's not to say there aren't other types of callback methods in JavaScript, but this section is focused on array methods that expect you to pass in a callback. So there's tons of them. We saw a bunch of built-in array methods early on, but we didn't cover these because we haven't talked about functions at that point. We didn't know what a callback was. It's a lot to throw at you at the very beginning when you're still wrapping your head around arrays. So we saw things like dot reverse or includes, index of. These methods we'll see are different. They're quite a bit different. We pass in a function, and the general pattern here is that we're going to run a function once per every element in an array, but we'll have different goals. Maybe we want to filter out certain values from an array. Maybe we want to create a new array from an existing array. Maybe we want to check if every single element in an array meets a given condition. What they have in common is that we are trying to run a function once per element in the array. So these functions we're about to see are extremely useful. I know I've said that a million times, but really the methods we'll see here are used all the time, far more often than things like index of or reverse. So our goals are pretty straightforward. We want to talk about the built-in methods for arrays that require callbacks, for each, map, filter, find, reduce, sum, and every. And our game plan here is to cover a couple of the easier ones, then take a break to talk about a different function syntax we haven't seen yet called arrow functions. Arrow functions are a new-ish way of writing functions. They're just shorter, cleaner, easier when you need to pass a function in as an argument. So we'll use them a lot for the rest of these methods that we'll cover. So we'll cover a couple of these arrow functions and then the rest of these methods. So in the next video, we'll start off with for each. The first of this new group of array methods we'll talk about is called for each. For each accepts a callback, it accepts a function, and it calls it on every element in a given array. It's an array method, so we call it on the array. Here's my nums array. We do nums.forEach, just like we would do nums.indexOf or nums.reverse. Both of the examples here are using anonymous function expressions. They're just one-time things that I'm trying to do. I could also create a function. I could define it first and then pass the name of the function in. But again, the goal of for each is that it takes whatever function you give it and it calls it on each element. It passes each value into that function. So let's try a simple example. I have an array called numbers. Not exciting, I know. 20, 21, 22, and so on. If I call numbers.forEach and I pass in a function, we'll start with an anonymous function here. I need to give it a parameter. I can name this whatever I want, but it is going to store, it will represent one element at a time. So the very first time for each runs, the first iteration, it will call whatever I have here, this function, and it will pass in the value of 20. So I'll go with num or n, it doesn't matter, element, L, something descriptive. And then I'll use num in here. We'll start really simple. We'll console.log num. And if I run this code, there we go, 20, 21, all the way to 27. So for each calls this function however many times it needs to, and it passes each element in one at a time. So we could also do console.log num times 2, just as a quick example here, and we get 40, 42, 44. Great. We could have also written a function ahead of time. Let's do print double. Let's do triple, just to have something a little different. And it will accept a single number, we'll call it n, and it will console.log n times 3. So now I have a standalone function called print triple. And I can call numbers.forEach and pass in print triple, just like that. So this is accomplishing the same thing. Well, we're tripling here instead of doubling, but it's the same idea. Numbers.forEach, this function. We're telling for each, here's the function I want you to call for each element. So internally, it would call print triple with 20, and then afterwards 21, and then afterwards 22, and it does it until it hits the end of the array. So if we double check this one, now we get print triple. I'll comment this out so we can just see it on its own. There we go, 60 down to 81. 20 times 3 is 60, 27 times 3 is 81. So two different ways of using for each. JavaScript doesn't care. They're both functions. The main difference is that this is a function we can reuse if we needed to, which is great. But a lot of the time with for each, and a lot of these methods we'll see in this section, you're just trying to get some code to run. You don't care about having a name for that function, being able to reuse it. It's just a one-time thing. So in that case, you would use an anonymous function, or it would make sense to at least. You don't have to. So we pass in that function, it's called. Let's do another example. Here I have a more complex array where each element is an object. Let's say I want to print out every title. We'll just start with that. I want to print each title. Using for each, I would call books, which is the name of the array, dot for each function, and we'll call this placeholder, this parameter, b or book. It represents one element in that array, which in our case happens to be an object. And then to print the title, I would just console.log book.title, and let's do .to uppercase. So if I refresh, we now get 4 different book titles in all caps. So for each is going to pass in each element. In this case, the element is an object. It's not a single number like we had earlier, it's a whole object. And then we can do whatever we want in here. Now you might be thinking, this doesn't seem that useful because we have things like for loops or for of. I could do the exact same thing using a for of. So I would do for let book of books, console.log, and I'll just copy that line over. We'll comment this one out. We get the same output. And you're right, this works. It is different. This is not identical. Obviously the syntax is different, but the key difference as far as JavaScript is concerned is here we have a function that's being called. This is just a block. That doesn't really mean much in this example, but I just want you to understand there is a difference. So yeah, you could use a for of loop. For each has been around much longer than for of. So we used to not have this option at all. We had a regular for loop for let I equals 0, I is less than books.length, I++, and then we would console this out, but we don't have book. We would have to do books of I.title.to uppercase, and this would give us the same thing, but it's just nicer, in my opinion, to do a for each or a for of where we don't have to use I. If we don't care about the index, we're not using the index except to access each element, then why use it? So for each was the alternative we used for a long time. People still use for each, but we also now have for of. You can use it to achieve the same end. So here are all 3 versions doing the same thing. Now there's one other thing to know about for each. We can also add a second parameter to our callback, to the function here, if we want to use the index. So if I wanted to print out each, actually let's do it up here. Instead of books, let's go back to numbers. If I wanted to print out the index and then the number using a for each, I could do numbers.forEach, pass in my callback. We'll call this num. And then the second parameter, this is how for each works, the second parameter will be the index, which we can call idx, index, and we'll just do a simple console.log index, comma, num. We run it, and there we go. 0 element is 20. Element 1, 21, all the way down to element 7, 27. So this is nice if you need the index. Sometimes you do. You could use a for each. There's not an easy way to get an index if you're using a regular for of. Although if you use a regular for loop, you definitely can get it. You have to generate it yourself using, I and I less than whatever, I++. With for each, you get the index for free. So what's happening here is that this function is being called each time for one element, and for each is passing in not only the element, but it passes in the index. And if you don't use that index, it's still being passed in. For each is just saying, here's the number, or here's the element, and here's the index for that element. You can ignore it. You don't have to accept it or do anything with it, but it's going to be passed in. And so if you want it, you can capture it as a parameter. All right, so that's for each. Again, it's the simplest of these methods we'll see. It accepts a callback and it runs that callback once per element in the array, where that element's value will be an argument to the callback. Next up, we have the array method that I probably use the most out of all of them. It's called map. Map is used to create a new array from an existing array. It could be used to simply duplicate an array, though there are easier ways of doing it, but it can also be used to extract portions of an array or to somehow transform an array into a new array. Double every number in this array, or reverse every string in the original and make a new array with those reverse strings. So it accepts a callback, just like for each. It calls that callback with every element in the array, but it builds a new array with those values. So here's a simple example. Here I have an array called texts. We have raffle, LOL, OMG, TTYL, 4 strings, lowercase, and I'm calling texts.map. I'm passing a callback function in. The parameter name I settled on was t. T represents each one of these strings. And I'm returning from this function t.toUppercase. And what this whole map does overall is it generates a new array, and I'm storing it in a variable called caps. So it does not alter or update texts. Its original values are still unchanged, but I've mapped them over to a new array called caps. So we'll take a look at a bunch of examples. I have 2 sample arrays to start, nice and simple ones. Let's work with numbers. Let's make a new array called doubles. Doubles will be an array where every value is double this value, the corresponding value in numbers. So we'll call numbers.map, and we'll pass in a function. Usually we use anonymous functions unless you have a predefined function that does exactly what you need. Usually these are one-time use things. And the callback parameter I'll go with is just num. That makes sense. It represents each number. Now what I need to do from this function is return a value. This is how map knows what values to add to the array. If I don't return anything, it won't work. So let's return num times 2. And if I run this right now, we don't get anything, or we don't see anything. Numbers is unchanged because map does not mutate the original array. It maps the values to a new array. So I need to capture that value. If I run this code in my console, you can see that it returns, map itself returns this new mapped array. So I'll capture that in a variable, const doubles. We'll try it again. And now if I look at doubles, it exists, and it's a double of this original array. So if I don't return something, I just console.log, or I'm simply writing this expression here. If we look at doubles, it's an array full of undefineds. Because map doesn't care what the return value is, it's going to take whatever is returned from our function and add it into a new array. 8 times because it ran our function 8 times. There's 8 elements here. And each time nothing was returned, and when a function returns nothing, the value you get is undefined, so it created an array of 8 undefineds. So we need to return a value here. There we go. Next, let's do another example with numbers once again, but instead of simply doubling the value, let's decide if the number is even or odd, and we're going to map them into a new array, where the array will contain, let's have it contain an object for each element, and we'll have the number set to 20, and then we'll set is even to true or false. And we'll do that for every single element in numbers. So to do that, we need to call numbers.map, pass in our callback function. I'll go with n as the parameter this time instead of num. And then we know we want to check if the value is even, and we want to return an object. So we can return an object here. We can do it all at once. We don't have to make it in a variable first and then return it. And we'll set value to be n. And then we'll set is even to be a Boolean, true or false, based off of n mod 2 equals 0. So this, if the remainder, once you divide by 2, is 0, that will return true. If not, it returns false. So we'll end up with the isEven property being true or false. And then value is just the number itself, n. So if we try this and save it to a variable, we'll go with const numDetail. I don't know, it's not a great name. Let's look at what we get. NumDetail is an array of objects, and each object has a value and is even. So we have value 21 is even false. Value 22 is even true. So there's one example. Now let's work with the array of strings. I have all of these abbreviations, and let's say I wanted to format them different. I want an array where each string is all caps and separated by periods, like ASAP should be formatted this way instead of ASAP. So I want to map them into a new array. What I need to do here, well, what I can do at least, is use map. If I didn't want to use map in all of these examples, I could do this manually. I could make a loop for let word, let's go with numbers just to do this doubles example. For let num of numbers, I need to make a results array. So we'll make our array, we'll call it doubles2. Const doubles2 equals an empty array. And then I need to push into doubles2 dot push num times 2. So I'm doing the same thing effectively. There's no function involved, but I'm iterating over numbers. For each number, I'm multiplying it by 2 and pushing it into an array. I'm actually doing the push one at a time. Versus when we use map, all we do is write a function, map calls that function, takes the result, and it puts it into a new array for us automatically, and it gives us that array. But if we verify that this works, doubles2, there we go. But again, this is not calling a function. For something simple like multiplying by 2, this is easy. But map is really, really useful, especially when we start to combine it with other methods that we'll see. So I don't want to give you the impression that you should do this, that this is easier, because it's usually not. I just wanted to kind of recreate the basics of what it's doing. So it makes that array for us, it starts empty, and then it calls this function, it gets a return value, it pushes that into the array, and then it does it again for the next element. So back to our words, we're going to call map, words.map. I'll call this word, the parameter here. Now the logic to get this to be an abbreviation where we have all caps and a period after every letter is a little tricky. It's not hard, but we're going to use a couple different methods. We're going to capitalize it first. So we're going to call word.toUppercase. Then the easiest way, in my opinion, to add a period after every character is to split the word into an array. So if we do it over here, if we had ASAP.toUppercase dot split, split wants to know where it should split, and if we give it an empty string, it creates an array with each character from that string. So each element is one character. So now I have an array. Then I can call .join on that array and tell it what to join those characters together with. So take each element in this array that we just created using split and join it together into one string separated by a period after each character, and there we go. So we can use that logic right here. Word.toUppercase.split on the empty string, which means split on every character. That gives us an array, and we can call .join on a period. So this is not going to work. What am I missing? I'm missing return. We have to return this from our function. And then let's capture the variable. We'll call this abbreviations. If we run it, we look at abbreves, we now have this array that we mapped. We took this array of values and we mapped them into a new array. The originals are unchanged, but we now have a new array. Remember, for each is similar, but we're not building an array with those values. For each is like half of map. It calls a function on every element, but it doesn't store them in an array. It doesn't return a new array. Map does. Map takes that function, it calls it, and it takes the return value and puts it in a new array, which is how we end up with this. Here's one more common use case for map. If we have a slightly more complex data structure, like this books array, we have a bunch of properties. We have title, authors, rating. If I wanted to create a new array that contained all the book titles in my library, I could use map. If I want to just extract or isolate the title, I don't care about authors, I don't care about rating, I can use map. To do that, I would map over books, so books.map. I pass in my callback, and I'll call the parameter here, let's go with B for book. And all I want to do is return the title. So b.title. Return b.title. And that's it. So I'm saying create a new array based off of this array. And the value I'm going to return that you should use to make that new array is only the title. So I'm whittling down this array of objects and turning it into an array of strings. Turning it into is the wrong term. I'm creating a new version based off of it. The original books is unchanged. I'm mapping it. So let's go with const titles. Let's look at titles. And there we go. I have whittled down the pieces I need. I've extracted them. I didn't change the original, but this is a really common thing to do. Sometimes you have complex data structures and you want an array of just one piece or just a couple pieces. You want a simplified form. We can use map to do that without impacting the original. We just return the piece or the pieces that we want to form a new array using. So that's map. Like I said, it's very useful. It helps us take one array and map it into a new array. We provide a callback function, and that callback is executed once per element in the original array, and the return value of our callback is what is used to generate the new array. Next up, a quick break from the built-in array methods like for each and map. We'll get back to them shortly, but first, arrow functions. Arrow functions are a new-ish syntax in JavaScript, an alternative way of defining a function expression. Notice up here, Internet Explorer is crossed out. Arrow functions are not supported in IE, but pretty much everyone uses them these days, and there are many solutions to make sure code will run in all browsers. You can write an arrow function, and then if it doesn't work in IE, it will be turned into some other code that does work. But that's out of the scope of what we're talking about now. Let's take a look at arrow function syntax. We write function expressions all the time. An anonymous function like this one here, we pass into map, or one that we pass into for each. We do this so much in JavaScript that it was decided that there should be a more compact syntax for defining function expressions. So it's another way of defining a function. We don't have to write the function keyword. Instead, we write our function like this. Parentheses, and the arrow, that's where the name comes from, arrow function, and then curly braces, although we'll see that sometimes those braces are actually optional. So in this video, we'll just take a look at a couple simple arrow functions. Let's try them out over here. If we wanted to write a function expression without an arrow function, we would do something like const square equals function, which accepts some number, and it returns x times x. To do the same thing with an arrow function, I'll comment that one out. We would do const square equals parentheses, no function keyword, x, or whatever our parameter name is, and then our arrow, return x times x. And if I run my code and I call square of 4, we do get 16. You can compare the two syntaxes here. Already, this one is shorter. We don't have to write functions so much. And this makes a big difference when you look at some existing code bases or some libraries where you pass a lot of functions around, you use a lot of callbacks. If you have function all over the place, especially if you have nested callbacks, you see function everywhere. It's like 90% of what your code is, versus when we use arrow functions, it's a lot cleaner, slimmer, and easier to understand. Now, arrow functions were not introduced exclusively because they are more compact or they're easier on the eye. There's another difference, aside from how we write them, there's a difference in how they behave around something called the keyword this. Now, we haven't talked about this in JavaScript yet. We will, and when we do, we'll address arrow functions. But with what we know right now, arrow functions work exactly the same way as any other function we can write. They're just shorter. So let's try one more. I'll define a function. Let's go with isEven. It accepts one parameter. We'll call this num. We write our arrow, and then we'll return num mod 2 equal 0. Let's call, oh, it doesn't like that I have two squares. Refresh my code. isEven of 4, that's true. isEven of 47 is false. There we go. One more arrow function with multiple parameters. Let's do, this is so boring, but let's do multiply equals, we write our parens, x and y. Just like we would with a regular function, x comma y, we just don't write the function keyword, and we instead add the arrow. And this will return x times y. We run multiply of 4 and 7, we get 28. The next video is going to be all about arrow functions and how we can sometimes make them even slimmer and cleaner. But first, I'm just going to show you 2 rules. When you write an arrow function, if you only have one parameter, you can actually leave the parentheses off. So I could rewrite any of these, not this one, but square and is even, like this. Those parentheses are optional only when we have one parameter. So if I run my code, is even still works, is even of 7 is false, is even of 8 is true. If we have more than one, we have to have those parens, otherwise JavaScript gets confused. It doesn't know what I'm trying to do here, and you can see my auto formatter here formatted it oddly, and I get an error as soon as I run the code. It doesn't know what's going on. We have to add parens if we have more than one parameter. If we have one parameter, they're optional, and it's a matter of personal preference. I like leaving them off, but some style guides, some companies you may work with will expect you to add them in. And then if we define a function with no parameters whatsoever, like const greet, which will just console.log hello or hi there. What do we do here? We have to have empty parens. We can't just leave it off. We need empty parens, and it will console.log hi. I'll run my code now. I call greet, and we get hi. So to wrap up, the basic rules of an arrow function are that 1, it behaves just like a function expression, where we declare it with a function keyword, but we don't have to do that. This arrow function has no name. We're simply creating an anonymous function expression using an arrow function. So we have the arrow, we have our curly braces, we return just like a regular function, we have our parameters, but we have a couple options. If we have no parameters whatsoever, we have to have empty parens. If we have multiple params, we have to have the parens there. But if we have one parameter and only one, then we can optionally leave them off. So this or what we had before, both are valid. Next, we'll see some nice optimizations, how we can actually write an arrow function without these curly braces and without having to write return. The arrow functions we've seen so far are already pretty compact compared to a regular function expression where we have to write the word function, but there's an even more compact way of writing some arrow functions. This only works in certain scenarios. It's called implicit return. Adding an implicit return to an arrow function means that you don't have to write the return keyword itself, and in some scenarios you can write a one-liner arrow function. So let's talk about when you can use this and how it works. If I have a simple arrow function, whoops, typing in the wrong area, called square, I know it's a boring one. It accepts a single parameter, we'll call it n. We return n times n. This arrow function consists of a single expression that we're returning. We're not doing some other logic first, we're not making a variable, we're not adding a conditional, we're simply returning an expression. In scenarios where you have one expression that you want to be returned, you can rewrite this arrow function using parentheses instead of curly braces. And if you do that, you can leave off the return keyword. So we could rewrite this as const square equals n, and then parentheses n times n. And that's it. You'll see if I even try and add return in there, it gets highlighted with the red squiggly of death telling me expression expected, not a return statement. It wants just the expression, and this value will be computed and returned. So if I run it, we'll do square of 8, 64. Square of 2 is 4. But we can make this even shorter by putting it on a single line. And we can do that in scenarios where it fits and it makes sense to put on a single line. We can leave off the parens. I'll comment that version out. And we can just do this right here. So this is equivalent to what we had right here. We're writing an arrow function, accepts a single parameter n, and it returns n times n. It's an implicit return, We don't need those parens if we're putting it on one line. But that doesn't mean we should always try and make everything on one line. If it's super long, if it's hard to read, put parens and just put it on a new line. So if instead of returning n times n, we had some array that we were trying to return based off of n. Let's just say it was a long array like this. This won't make sense to JavaScript. None of those are valid identifiers or existing identifiers. But if I had this is a bit long for a single line. So we add those parens. It's just a way of making it clear that this whole thing is the expression, not just this one line. But let's go back to what we had before, n times n. Make sure it still works. Square of 2, square of 7, 49. It's working. So this is a really nice feature when you need a simple arrow function, which a lot of the time we do need when we're using all of these callback methods we've seen for arrays, for each, or map. A lot of the time we just want a single short expression to be returned, so we can use this one-liner syntax. One last thing, before we see some examples using array methods, I'll just show you what happens here. If we had some additional logic, let's say we wanted to check if n is positive. So if n is greater than or equal to 0, or let's just say it has to be greater than 0, then we'll return something. Let's do it the other way around. If it's negative, we'll return false. This is a problem. I have multiple expressions, multiple lines. It's not just multiple expressions. I have statements, I've got a conditional, then I have this expression at the bottom. This function does not know what it's supposed to return. JavaScript does not know what to return. There's multiple things that it could return, and this is an invalid arrow function. We can't do this if we're trying to use an implicit return. We only get one thing, one expression to return. That way there's no doubt in JavaScript's mind. It knows this is the one thing to return implicitly. Okay, so let's see some examples now. All right, so I have a simple array of nums. If I wanted to double every num and map it into a new array, I would call nums.map. And without an arrow function, it would look something like this. Function for n, we want to return n times 2. And if we save that to a variable, we'll call this nums. How about doubles 1? We look at doubles 1. This should be review. Oh, I didn't run my code. Try that again. We get 2, 4, 6, 8, and so on. If I wanted to use an arrow function instead, I can do doubles 2 equals nums.map. And if we use a non-implicit arrow function, a regular arrow function, we would have n and then return n times 2. Refresh our code. Doubles 2 looks the same. But we can make it even shorter with what we just saw. Doubles 3 equals nums.map. We'll go with the parameter name of n times 2. And that's it. Much, much shorter. We don't have to add curly braces. We don't need to add return. We simply write an arrow function on one line. When we have a single expression, this works great. Let's look at doubles 3. It looks identical. So this is really nice, and this is one of the main reasons arrow functions were added in. We use callbacks so frequently that there needed to be a nicer, more compact syntax. Remember, later on, there is another distinction between arrow functions and regular functions. We'll talk about that. It has to do with the keyword this, but we're not there yet. Let's do another example where we map these numbers into an array where we have the values even and odd, the string. So we would have odd and then even and then odd. As you can see here, we would just alternate. If I wanted to write that function or that map, how about const parity list? Parity is the term referring to if a number is even or odd. I'm pretty sure that's what it's called. Anyway, nums.map. Let's use a regular function first. Function for n. If n is mod 2 equals 0. If n mod 2 is equal to 0, we will return even. Otherwise, we return odd. If we look at parity list, we get odd, even, all the way down. Let's rewrite this with an arrow function. So it will be similar. We'll have nums.map and then n with our arrow, and we could leave it like this, and it still works. We look at parity list. But if I wanted to use an implicit return, no dice, at least not with this version. We could rewrite this to be a one-liner. We're really just doing a simple if and an else. One condition, if that's not true, do this instead, even or odd. And we can use the ternary operator to do this in one line. Remember, we only get one expression. Here we have multiple. This will not work. If I try and rewrite it using parens, we're out of luck. If I replace those curly braces with parens, JavaScript still does not like it. It tells us expression expected. So we can rewrite it like this with the ternary operator. If you remember this syntax, n mod 2 equals 0 question mark. So if this thing, we want to return this value, even, colon, that means otherwise, we'll return odd. And this is a one-liner. This works. Refresh, look at parity list, we're good to go. And if you wanted to, you could put this actually on one line instead of using parens. We just bring it up like this. It's a little long, but I also have my font zoomed in a bit. It's up to you if you want to do it on one line. I think sometimes people go overboard trying to fit something onto one line just so they can say they've done it. It's easier to read this, in my opinion, but in a simpler example like this one here, it makes a lot of sense to put it on one line. There's no reason for the extra lines and extra characters. Okay, so this pretty much concludes our little arrow functions interlude. Arrow functions are really, really useful. They don't do anything that you can't do with a regular function, at least with what we've seen. They're just a replacement that is more compact. So even in their most verbose form, it's still shorter. If you compare this to a regular function expression, we don't have to write function. We just write our parameter, optional parentheses around it. Remember that from the last video. You can put parentheses there, it's up to you. And then the arrow, curly braces, return something. Or we can use an implicit return where we don't have to write return, but we can only have a single expression in the body of the function. And if it doesn't fit on one line, like I don't think this one fits very well, you can use parens to wrap it, but it still needs to be a single expression. Okay, so that's arrow functions. Now we'll pick back up with more of those built-in array methods. The next one of these array methods that expects a callback is called find. Find does pretty much what it sounds like. It finds an element, it retrieves an element from an array based off of a function that we pass in. So this function needs to return true or false. And each time, find will call that function with one of these elements. And if that function returns true, then it's done. It will return to you the value of that element. So it only returns one value, one element that matches. Even if there are 10 matches in a given array, it stops after it finds the very first one. So here's an example. I have an array called movies. It has 4 strings. Every movie has either Mr. or Mrs. or both in its title. If I want to find the first movie that has the string Mrs. in it, I could do movies.find. I'll do an arrow function. I'll call the parameter movie. And this needs to be a Boolean function that returns true or false. So how do I figure out if movie contains Mrs.? I have a couple ways, but I'll do movie.includes Mrs. And I need to make sure I return this if I'm not going to use an implicit return. And then I'll save this to a variable. I'll call this const movie. Let's see what happens. We'll look at movie, and it contains Mr. and Mrs. Smith. Now movies is unchanged. All we're doing is a simple find, a search. We're not removing or updating movies in any way. So this function right here, again, has to return true or false, and the first time it returns true for a given movie, a given element, find is done, and it returns that movie. So the Fantastic Mr. Fox was movie the very first time through. It was plugged into this function. It does not include Mrs., so it returns false, which means find moves on to the next element. Mr. and Mrs. Smith, that became movie. Movie.includes Mrs. now is true. This returns true. So then find stops everything, and it returns this string right here. If I wanted to instead find the first movie that starts with Mrs., not just includes Mrs. somewhere, I could write it as const, I'll just do movie2 equals movies.find. We'll do an implicit return this time. M, I'll do parens to start, m.index of Mrs. I do need to pay attention to capitalization or downcase everything. I want that to equal 1. That would mean that misses, actually, what am I saying? I want it to equal 0. That would mean that misses comes at the very beginning of the string. And that should match Mrs. Doubtfire, but not Mr. and Mrs. Smith. So let's see if it works. Run my code, movie 2, we get Mrs. Doubtfire. Again, this first one was looking for anything that contained Mrs. anywhere. We do have 2 matches, but this one doesn't matter, it's never found, because find is going to stop after the first match. It returns Mr. and Mrs. Smith. The other movies, there could be 1,000 other movies, they don't get looked at, they're passed over. This arrow function we wrote here, we could just do on a single line if we wanted to. For me, it's a bit long with my editor zoomed in, but it's not too bad. So this works if you want to do it that way. Now let's do another example with a different data structure. Here I have that books array we've been using for a couple examples. Each book is an object. It has a title, authors, which is an array, and a rating. If I wanted to find a book that had a rating greater than 4.3, I would do books.find. Arrow function, I'll just go with b as the parameter. b.rating, if I can spell rating, is greater than or equal to 4.3. And we'll save that to a variable, const good book. Let's take a look. Good book is Bone, the complete edition. Great graphic novel, by the way. Rating is 4.42. It gave us the first match. We could also do something like find the first book where Neil Gaiman is an author. So const Neil book equals books.find b. We want b.authors dot includes Neil Gaiman. There we go. And I think that one's good enough for one line. It's not that long, but just to have a little variety, let's do it with parens. There we go. Let's take a look. Neil book. And it gave us Good Omens, the first book where he's listed as an author. So this one doesn't matter because find only gives us the first match. So find is really useful when you're trying to, for example, find something based off of an ID. If you have a list of comments or how about a list of posts that a user has created and they've clicked a button to delete one of those posts. If it's a web app, they want to remove it. When that button is clicked, most likely you'll end up sending an ID. You'll call a function with an ID of that post. It will be something like delete post with ID of 2. It would be something like this. You would have a function called delete, maybe delete post. You'd pass in 2, and then you would use 2 to find the post with that ID. So you might do posts.find for the post parameter p.id equals 2. And maybe instead of deleting, you wanted to update. So you would find the post and then update the post based off of that ID. We use find a lot, especially when we're looking for something based off of an identifier, a username, but remember, it only gives us the first match. Next up, we have yet another array method that expects you to pass in a callback. It's called filter. Filter allows us to filter out subsets of an array. Basically, we pass in a function which returns true or false, a test function, and if an element passes that function, it will be added into the returned or the result array. So if we had an array of a bunch of numbers, we want to create a new array with only the evens, we could filter the evens out. It doesn't update the original, it doesn't mutate it, so filtering it out makes it sound like we're removing them. We're really just creating a copy with specific targeted information or elements. So let's do a couple examples. We'll start simple with numbers. I know it's boring. Const nums equals, and I'll just type some random numbers in here. That's good enough there. And if I wanted to filter so that I get a new array only with odd numbers, I could call numbers or nums.filter, and I'll use a single line arrow function, implicit return, n is my parameter, n mod 2 equals 1. That's how we know if something is odd. So this function right here is a Boolean function. It's what's called a test function, at least if you look at the docs for filter. It returns true or false. So filter is going to start with an empty array, and it's going to try 34 and pass it into our test function. Does that pass? Do we get true? No, we do not, because this is even. So it goes to 35. That does pass this test. It returns true. So 35 is added to the result. And then 67 would be added. And then 54 would not be added. And then as soon as it hits the end of the array, it returns this result. So I can save this to a variable called odds. Let's check it out. There's odds. It contains the 4 odd numbers. If we look at nums, it's not altered in any way. So we're not removing them. We're simply creating a new array with those values. We could do the same thing for evens. It would be a very simple change. Name the variable evens, and then say num mod 2 equals 0. There's no remainder when we divide by 2, so nums is unchanged, but now we have evens containing the even numbers. If I wanted to get large numbers, I'll call them big nums. I could do nums.filter with the parameter name of n again, where n is greater than, how about 50? So this will give me an array of numbers where each number is larger than 50. I need to save my code, run it over here. We'll look at big nums, and now we have 67, 54, 109, and 102. So we write a function that returns true or false. If that function returns true for an element, it's added into the result that we get. Otherwise, it's ignored. Let's do a few more complex examples. I've updated this books array to include more books, but also each book has some new properties. We have a genre or genres property, which is an array of genres. We have more books. They each have a rating, and that's pretty much it. There's, 10 or so books in here, maybe 8. Now imagine that we're actually creating a e-commerce bookstore or a website like goodreads.com where you can search for books, add them to your reading list, and it's a social network for books. A lot of the time we want to give users the ability to search for things, to search for a book based off of a title, or to narrow down search results so that they could check a box that says rating, 4-star or greater rating, or only fantasy books. We would use filter to narrow down the results that we're showing. So let's do a couple examples. Let's start with a simple one. Let's select the ratings or the books that have high ratings. So their rating is greater than maybe 4.3. So that would be const good books equals books.filter. For B, we want B to be greater than 4.3. Let's see what we get. Good books. All right. Well, that's my fault. I'm comparing the entire book. This is an object. I need to compare b.rating. Try that again. And now we have 4 books. Bone, which has a rating of 4.42. Gentleman in Moscow, great book, 4.36. Name of the Wind, 4.54. And The Way of Kings, 4.65. Okay, so we just grabbed the highest rated books, but again, books is unchanged. It still has 9 books in it. If a user then wanted to pivot and look at, let's say, only fantasy books, let's filter where genre includes fantasy. So we have a couple of them here. In order to do that, we'll use filter. So const fantasy books equals books.filter. This one is probably going to be a bit long for a single line, so I'll do for each book, or that will be the name of the parameter. I'll use an implicit return with parentheses. We want book.genres.includes fantasy. We could do this on one line, but oops, no semicolon in there. And let's see what we get. Run it over here. Fantasy books. We get 5 books. Each one should include fantasy as one of its genres. So this one has fantasy. This one has fantasy. American Gods. Bone has fantasy. And Good Omens does as well. Okay, let's do another example where we filter for short form books where basically it's either essays or short stories. I don't know what you would call those. Small books made up of smaller pieces. Anthology books. We'll call it short form. So const short form equals books.filter. Book is our parameter name. And then I'll do another implicit return. We want to check if book.genres.includes either short stories. Let me just make sure it was short stories plural, or I want essays. So I'll do or book.genres.includes essays. Let's see what we get for short form. We have two results. The first one is Changing My Mind by Zadie Smith. In genres, we can see essays. The second one is by Richard Powers called The Overstory. Really cool book. Short stories is in genres as well. So a whole bunch of different ways to filter just this one array of books. Think of any e-commerce website. You can filter by rating. You can filter by searching for something. So let's try that. Let's search through a title and find books that contain, I don't know, the in their title. So to mimic a search box, let's make a variable called query. And this will be coming from a user. We don't know what it is, so I'll leave it blank for now. And then we'll do books.filter. I'll save this to a variable called results. And we'll filter where the book title includes that query. And to be extra sure, we'll also downcase everything, so it's case insensitive. So book, we'll do book.title.to lowercase dot includes, and then I want to make sure I'm lowercasing the query as well. Query.to lowercase. Let's give this a bit more room. And honestly, in this scenario, this is fine as a one-liner, but just for some variety, I'll break this up. So I'll use a regular arrow function where I need to explicitly return something. So I'll extract this to a variable. I'll call it title equals books.title or book.title.to lowercase. And then I'll just do return title.includes query dot, not local lowercase, regular lowercase. All right. So whatever the user searches for, let's say they're searching for, is there anything we could get multiple results with? I guess we've got the. It's quite boring, but if a user types the, we're going to downcase this right here, and we're going to compare it to every book title by downcasing the title so that we don't care about casing at all. Then we'll just check, does each title include that lowercase query? If it does, this returns true. It gets added to our results. Let's run it. Let's look at results. We get 5. They all contain the. Bone, the complete, complete journey, complete story, complete edition. The Name of the Wind, the Overstory, The Way of Kings, and Lord of the Flies. Here we don't have an uppercase the. Here we do have uppercase the. So those are some examples of using filter. It's a great method. There's so many applications where you need to narrow down an array to a smaller portion. Remember, you're not actually updating or mutating the original, but it gives you a return value that you can save and then work with. So I use filter all the time, and it's relatively simple. You pass in a test function that you write. It returns true or false. If it's true for a given element, then that element is added to the filtered result array. Next up, I'm grouping two array methods together. They're called every and sum. So both of these methods are Boolean methods. They return true or false. At the end of the day, after they run, you get true or false. So every is going to accept a callback, which itself needs to be a Boolean callback. It returns true or false. It's a test, and it runs that function on every or with every element in the array. And if it gets true for every element, then the whole function, the whole method of every returns true. So it's a way of verifying or checking, does every element in this array have 3 letters, or does every element end with the letter G? So as an example, let's try this out. We have a words array over here. If I wanted to check if every word has a length of 3, I would do words.every, and then I pass in my Boolean function. This function, also called the test function, needs to return true or false. So I'll say for every word, does that word.length equal 3? And I'll save this to a variable called all 3 letters or something. Not the most graceful variable name. let's run it and see what we get. All 3 lets is true, but as soon as I change one of these to be 4 letters or 2 letters, and I run it again, it's false. This function has to return true for every single element in order for every to return true. So let's go back to what we had. We could do another test if they all end with the letter G. So that would be words.every. And I'll do this on multiple lines just so that we have some diversity here. For every word, that will be our parameter. Let's calculate the last index. So we'll go with last equals, and then word.length minus 1. That gives us the last index. Remember, length is always 1 more than the last index. And then we'll use that to return word of last triple equals G. So we're getting the last index, which for all of these, there are only 3 letters, so the last index will be 2. And then we're saying, is word of 2 equal to the letter G? And save that to a variable. Let's go with const all end in G. And if we check over here, all end in G is true. But of course, if I change one of them to be bat with a T, it's no longer true. So that's every. It takes a Boolean function, it runs it on every element in the array, and if it always gets true for the entire array, then every itself returns true. Next we have sum. Sum is similar. It does kind of the same process, but it only cares if any of those elements pass the test. So if there's at least one element in the array that passed the test that returned true, then the entire method of sum returns true. So with this example array of words, if I wanted to check if some of the words start with D, it would be words.sum, and then word, we'll do word of 0 equals D. So this is a Boolean function we pass in. It has to be a true or false returning function, and sum, we'll call it once per element. And as long as it gets 1 true, that's all that matters, words.sum will return true, or the sum method. So we'll go with, I don't know, these variables are really hard to name. Const sum start with D. That is quite the lengthy name. Let's check it out. Some start with D. Yes, that is true. We have 2 elements that start with D. If I instead did words.every word starts with D, we'll call this every, or all, start with D, we get false, as you can see here, versus some start is true. So the only difference here was some and every. Some needs just 1 element to return true. Every needs all of them to return true. Let's try one more every. We'll do words.every. Actually, let's bring our books back. And let's try a couple more examples with our good friend, this book array. Let's write some code to check if every book is at least 3.5 stars or 3.5 whatever rating or higher. So we would call books.every for each book. We want to know if book.rating is greater than 3.5. And we'll save this to a variable, all good books. Let's take a look. All good books is true. If I instead did 4.5 and higher, that's false because we have plenty of books that are not 4.5 or higher. So let's go back to, let's leave it at 4. 3.5. I think all of these books are good. I would feel bad saying that one of them is not good. Some of these older books, Lord of the Flies, people always rate them lower. And let's write one more to see if any of these books have 2 authors. So that would be const, let's go with any 2 authors, equals books.sum, book.authors.length equals 2. So we're passing in our function, the test function. It will return true if a given book has exactly 2 authors. Authors.length is 2. And we're using sum, so we just need one of them to be true. We'll run it. Any 2 authors is true. Okay, so that is sum and every. They follow a similar pattern, but they behave differently. Every needs every element to pass this test. Sum just needs one to pass. Next up, we have another array method we've actually seen before, but when we saw it earlier, it didn't really behave the way we wanted it to. So the method is sort. Here I have an array called prices, and it's full of numbers representing prices on a website or who knows what. When we called array.sort or prices.sort early on, when we talked about array methods, back when we were covering index of or reverse, those sort of methods, we didn't know about callbacks. We didn't know about functions even. So when we call prices.sort, the default sort in JavaScript, it's very weird. I have no idea why this decision was made, but the default, as we've already seen, is to convert all of these numbers to strings and sort them as strings, and that leads to some very odd behavior. If I run this code, prices.sort, just do it over here, you can see it ends up sorting them by the first character. So 1 before 3, and it's sorting them based off of strings rather than sorting them by actual value. So we end up with 9 at the end of the array. Oh no, that's 99.99. Okay, well, we end up with 99.99 at the end when we have 3,000 and 9,500 and 405 or 400.5. Those should all be greater, but the sort doesn't really work the way we want it to. So back then I said, once we talk about functions, we'll see how to use sort and how to customize its behavior. This is how we do it. We pass in what they call on the docs a compare function. Now this function has two parameters. You can call them A and B or first and second, and we need to return a value, a number from compare func. If that compare func returns a negative number, the function will sort A before B. If it returns 0, it does not change the order, and if it returns a number greater than 0, it will sort B before A. So this is always kind of confusing to explain when you look at it this way. It may not make a lot of sense, but let me show you how we would use it here. So if we do prices.sort and we write our function, a compare function, it needs to have two parameters. A and B is fine. Then the standard sort would be A minus B. And let me just show you what we get first. I'll save this to a variable. Const sort1. Let's look at sort1. We end up with 12, 35.99, 99, 400, 3,000, and 9,500. We are sorting in ascending order from smallest to largest. If we come back to this chart, remember that if the compare function returns a negative number, it sorts A before B, where A is the first element, B is the second. If it's a positive number instead, it sorts B before A. So if we walk through this with a simple example, the first time this callback is executed, we have 400.5 and 3,000. So if we have A and B, we have, I'm just going to do 400.5 and then 3,000. And the way our compare function is set up is that it returns A minus B. So 400 minus 3,000 is going to be a negative number. So what does it do with a negative number? It sorts A before B. So that means that it's going to sort 400 before 3,000. Then let's say we were comparing 35.99 and 12. At that point, A would be 35.99, and then we have 12.0 for B. When we subtract A minus B, 35 minus 12, that gives us a positive number. And when we have a positive number, it sorts B before A. So that means 12 would go before 35. And if we had two numbers that were equal, then they would be treated as equal. We wouldn't put one before the other. We'd keep the order unchanged, at least between those two values. So if we wanted to sort the other way, let's call this const ascending sort. If I wanted to do a descending sort, any ideas here? We would do prices.sort. We have A and B. Let's do, instead of A and B this time, X and Y. And then we want to return Y minus X. So this is the other way around. And I kind of just made a horrible decision to name it X and Y from an educational point of view, because now you can't compare these as easily. So I'm going to redo that. Okay, so A and B, same order here, but now we're returning B minus A. So if A is 1,000 and we're comparing it to B, which is 4,000, in this case, we're doing B minus A. So 4,000 minus 1,000 gives us a positive number. And when we get a positive number, sort B before A. So that means moving the larger numbers to the left side of the array, sorting them in descending order. So this one change, A minus B versus B minus A, or first thing minus second thing versus second thing minus first thing, makes a significant difference. So we look at descending sort. It's going from 9,500 all the way down to 12. So the greatest number is first, the smallest number is last. There is a problem though. If we look at ascending sort, it looks like, it is exactly the same thing, but that's deceiving. Remember that sort is one of the few array methods, at least one of the few callback array methods, that actually mutates the original array. So we sorted it one way, in place. We're actually updating prices. And then we sorted it another way here, in place. So we lose this effort. It's gone. We're just making another reference to the same array. So we have three variables pointing to the exact same array. If we look at prices, it's also updated. It's just one array in memory. So if I wanted to just have two clear different results where I was not sorting the same array, I could either declare two variables, prices1, and then make a duplicate of prices2 with the same data, or I could use a method to copy the data into a new array. So something like slice right here. If I slice first and I don't pass anything in, if I call prices.slice, it makes a copy of that array. We saw this behavior earlier when we first talked about slice. So this is not something you would normally do unless you really did not want to sort in place. It's pretty rare that you're going to sort ascending and descending at once. Maybe you'll allow a user to toggle between them, but then you can just have one array that is going from ascending to descending. But when I'm teaching, I want to show you both so that you can take a look at both of them at the same time. Let's make another variable here called bad sort equals prices.slice. So I'm just making three copies. Each one of these variables now is not connected to the original prices. They have the same data, but they're not the same reference. And let's see what we get. So we have our bad sort first. This is the one based off of strings. I shouldn't call it bad sort, but it's bad when you're sorting numbers. Then we have our ascending sort, where we go from smallest number to the greatest number. That was using A minus B, first minus second. And then we have our descending sort, which goes the other way, B minus A. So it returns a positive number when this version would have returned a negative number, and vice versa. So 9,500 down to 12. Okay, now the last thing I'll show you is how to sort something that is a little more complex. Rather than a single array of numbers, let's go back to our books array. Okay, I've copied the books array back in. We have 9 books. They each have a rating. I think that's the logical thing to sort by. So we'll write our sort, and we'll do this one in place. Books.sort. It always happens in place, but we won't make a copy of the array. We don't care about the original order. Let's just mutate this array. So books.sort, we pass in our callback. I'll go with A and B again. But this time, we can't do something like A minus B because A and B are both objects. They're referring to one element in the array at a time. That's one element. That's another. How can we compare, or how can we run one object minus another object? We can't. So what we need to do is compare based off of rating, which is easy enough. It's just A.rating minus B.rating. And let's take a look at books now. Before, the first one was 4.25 for Good Omens, 3.83 for Changing My Mind. If we look at books over here, not bookos, but books, we end up with first Lord of the Flies, 3.67. Then we have Changing My Mind, 3.8. American Gods, 4.11, all the way down to The Way of Kings, 4.65. And we could reverse it if we wanted to by going the other direction. If we wanted highest rated first, we would do B.rating minus A.rating. Now you can do more complex sorts instead of just comparing based off of one value. Here we're only sorting based off of rating. You could write a more complex function that sorted based off of rating and also sorted based off of, the genre, or if you had different types of ratings, like for audiobooks, you have ratings for the book itself and the story, and then ratings for the performance quality of the person narrating it. So you have two different ratings, and if you wanted to sort descending based off of primarily the story, but then secondarily also the performance, you could write a more complex function. But this is good enough for now. Let's look at books now. And what do we have? Up first, let me expand this. We've got Way of Kings 4.65. And that is sort. So we saw the very, very basics of sort back when we covered arrays and array methods before we talked about callbacks. And it wasn't that useful. I guess if you need to sort strings, it's fine. But if you need to sort numbers, you need to pass a callback in, a compare func, and it needs to return a number. If it's a negative number, one thing happens. If it's a positive number, something else happens. Okay, so that is sort. Last, but certainly not least, we have reduce. Reduce is a built-in array method. You pass a callback to it, just like all the methods we've seen in this section. I saved it for last because reduce is a bit different. It's really useful and versatile, but it also is a little tricky to explain. So this image is not here for you to be afraid of reduce. It's here showing you my own fear of teaching reduce. Every time I teach it, it goes well enough, but I always feel like I could have done that better, and I'm always worried. I'm not actually stressing about it, but it's always something that I worry about making better because it's just not that easy to teach. Reduce is something that you just need to practice in order to get good with it. So what is reduce? Why is it even named reduce? We've seen many like for each. That seems like a pretty standard name. It does something for each element. We've seen every or filter or sort. Reduce is maybe not as intuitive, but here's what it does. It takes an array of values and it reduces them down to a single value, which is what this little diagram is. I spent a long time working on this. It's all just clip art, but I couldn't find the right stuff. The idea is each one of these is maybe representing an element in an array, and they're being combined and reduced down to a single droplet of liquid. So applications for reduce include things like summing every element in an array. That's probably the simplest one we'll start with, but it's not always about summing or multiplying or accumulating data in one number. It could be finding the maximum value in an entire array. We're reducing this array of 100 numbers down to one maximum. It could also be tallying votes or tallying data in an array or in an object. So I'm going to split reduce into a couple different videos. We're going to start with the basics here. We're going to talk about how it works with the simplest example of summing every element in an array. So reduce is an array method. We pass in a callback, and that callback needs to follow a particular format. That format looks like this. It's a callback with at least two parameters. Now the documentation calls this first one accumulator. Other people will call it total, but this is the variable or the parameter that will store the end result of reduce. And then we have current value or val or element. This represents each individual element in the array as reduce works its way across. So it doesn't matter what you name them, but the first parameter here will store the total or the accumulated value that we're reducing down to. And then current value, or just the second parameter here, stores each individual element. So this example sums all numbers in this array. If we take a look at this table, I think it helps explain how it works. The accumulator variable is going to start as the first element in the array, and current value starts as the next element. And if you look at what we're returning, accumulator plus current value. So take the current total, which is initialized to the first element, 3, add it to the next value, 5, current value, that gives us 8. So we return 8. That is then used as accumulator in the next iteration. So accumulator now remembers the last time, the last sum, which was 8. So now accumulator is 8 and current value is the next element, 7. So we add them together and return that, which is 15. And now reduce runs again, or the callback rather runs again. Accumulator is now 15. It remembers the value from last time, the sum or the total. And current value is 9. So we add 15 and 9, that's what I'm reducing, or how I'm reducing. We get 24. It goes one more time. Accumulator is 24 on the fourth call. It holds the sum of all of these elements before it, and now current value is the last element, 11. So we return the sum of 24 and 11, which gives us 35. And we've hit the end, so reduce returns 35. That is the total accumulated value. So we end up with 35 as the return value. So again, think of it this way. We're taking a bunch of values and we're reducing them down to a single value. And the function that we pass in has to follow this format, where the first thing is a total or the accumulator or just the value that you are reducing, and it will hold a value each time that changes, or it can change. So every time this function runs, it's passed the previous return value of the function. And then current value is whichever value we're working on. So let's try it again. Let's do something slightly different. Let's do a simple array. We'll go with nums just to keep it easy. Let's go, how about 3, 4, 5, 6, 7. Okay. And then if we call nums.reduce, and I want to multiply all numbers together and end up with a product of all of these numbers, I need to pass in my callback, which follows that format. You can see here I'm actually getting the autocomplete or the preview, where the first value or the first parameter, they call it previous value in VS Code, and current value is the second parameter. Let's call this one total instead of accumulator. Accumulator sounds a little intense. So total and then curval. I guess current val is fine. And then I'll do an arrow function. So I need a set of parens around the two parameters, and then my arrow. And I won't do this one on one line. We'll return manually. I want to multiply total by the current val. And then let's save this to a variable. Const product equals. What does product equal? We get 2520. Okay, I guess that's probably right. Let's see. 3 times 4 times 5 times 6 times 7. There we go. Okay, so if you feel like you understand how it works, you can go ahead and stop watching this video and move on to the more advanced ways of using reduce, which is the next video. But if you want to step through this step by step, let's go ahead and do it. So the very first time reduce calls our callback, total is going to be initialized to the first element. So I'm going to make a little table here. We'll go with total, and then all the way over here, we'll have current val. So the first time through, it initializes total to 3, right there. Then current val is going to be set to the very next element, which is 4. And we are returning total times current val. So we return 12. And reduce remembers that if we want to personify it. It remembers the previous return value, which was 12. So it uses 12 as total the next time through. It passes 12 as a total, and then current value is going to be 5. So we get 12, and then all the way over here, I don't know why I made it so far away, we have 5. Now what's 5 times 12? What is that, 60? Is that right? Yeah, right? Okay, so the return value is 60 this time. And 60 is now the new total, and current val is going to be 6. So we have 60 and then 6. And then the callback is called one more time. 60 times 6 is 3,600. No, 360, excuse me. So that is the new total. That is returned from this iteration here. Return total, 60 times 6, that's 360. That is the new total, and the final value in the array is 7. So we end up now with 360 times 7, which gives us 2,520. So that is a step-by-step walkthrough. Remember that the first parameter is the total. It is the thing you are boiling down to, you're reducing down to, and you're keeping track. It persists. You can think of it as having a memory throughout this whole iterative cycle. And then current value changes every time, depending on which iteration we're on, which element we're actually using. So this is a simple example of multiplying everything. We saw how we could sum all elements in an array. Next, we'll see some more advanced use cases for reduce. All right, so we saw how we can use reduce to sum all elements in an array or multiply them all together, and that's one use for reduce. but there are many other things we can do with it. We don't have to be accumulating a value through math. We don't have to be multiplying or adding or subtracting or dividing. We can also do things like finding the maximum value in an array, where the accumulator is really just tracking the max. It's not being added to or multiplied or anything like that. It's simply referring to the current maximum value. And then we potentially update max if we find a larger value. So let me show you a quick example. Here we have grades, a list of grades, an array. If I want to find the max, what I could do is grades.reduce. I'll save this to a variable called maxGrade. And we need to pass in our callback, which follows the format of accumulator first, and then current val next. But instead of calling this accum or accumulator, I'm just going to call it max. Then I'll add my arrow function syntax. And what we need to do is check if the current value is greater than the current max. So the first time this runs, we'll have max start at 87. Just like when we summed an array together, the first total started as the first element. So max will be 87, and then current val, we'll go with, let's do cur val here. Cur val will start at 64. And then we do a comparison. Is current val greater than max? If cur val is greater than max, if it is, then we will return cur val. And if this is not the case, we'll return max. So whatever is returned from this function will be used as the next max. So the first time through, max is 87, current val is 64. This is not true. Cur val is smaller, so we return max. So if we add our return here, I should comment this whole thing out so we don't get syntax errors. That return is going to be 87, return max. When we return that value, max then uses that previous return. So we returned 87, max is 87 once again. But next time, cur val moves on to 96. So now cur val is 96. We do the comparison. Cur val is now greater than max. 96 is greater than 87, so we return cur val, which is 96. And that return value is then used to set the new max. Max, the third time through, is going to be 96. And then we're comparing it to cur val, which is 92. And I won't waste your time going through this entire thing, but this time through, we return 96. We just return max as is because this is not true. And eventually we go all the way through the array and we find the max. We return that max, which eventually is 99. Then we compare it to 73. We keep returning 99. 99, 99, and then reduce returns that final return value, which is 99. So let's run it and just make sure I'm not crazy. Let's take a look at max grade. It is indeed 99. We could also rewrite this in a pretty different way. There's a couple different approaches using reduce. If I comment this out, instead of returning cur val or returning max, we can use the built-in math.max. So math.max, you pass in two numbers like 3 and 5, and it will tell us the maximum number. 3 and 10 is 10. 9 and 1, we get 9. So we could use that and replace this whole line with return math.max of the current max and the current val that we're looking at. If we run it, max grade is still 99. And we could also write a min grade, keep this exactly the same, although I would rename this to be min. This represents the minimum value that we are keeping track of as we go through. As reduce calls our callback over and over and over, it will pass in the current min. So return math.min. And if you wanted to, you could even use an implicit return since we have a single expression there. Get rid of the return keyword. Let's look at min grade. Oh, max is not defined. I need to update that to be min as well. So min grade is now 64, max is 99. So same logic, just wrote it in a different way. Here we're doing the math ourselves, or the comparison. Here we rely on math.max. But what really matters is the way reduce works. So we're not summing things together, we're not multiplying them into a accumulator variable. The term accumulator or total kind of makes me think of something that is growing or getting bigger, but that's not what happens here. This parameter, which we're calling max, is simply pointing to one value and then potentially pointing to a different value instead. As soon as we find a new max, it updates to be that max. So it's not accumulating so much as just keeping track of the max. And before we move on to our third video on reduce, which I'll show you some more interesting or different use cases for reduce, that's coming up next. Before we do that, there's one extra argument I haven't mentioned. When you use reduce, you can actually pass in an initial starting value. So after your callback, the format would be something.reduce. So we'll do array.reduce. You pass in your callback and then initial value. Now this callback is usually an inline anonymous function, so it ends up being kind of long, but at the end, after your function, you can add a comma and then an initial value. So if we write a simple reducer function, let's just go back to adding numbers together. So we'll do, how about 10, 20, 30, 40, and 50 dot reduce. Add in our arrow function, we'll go with sum, and then let's go with cur val. Right now, if we return sum plus cur val, and let's store this in a variable, const sum. Let's look at sum. It's 150. Is that correct? Let's see. I think that makes sense, right? 50, 100, and then 40 plus 10. Yeah, 150. When we don't specify an initial value, it will just use the first element, which we saw a couple slides ago here, where the accumulator starts as 3. That's the first element. And the current value starts at 5. But you can initialize with a custom value. So I can say, I want sum to start at 0, which is going to give us the exact same result. We start with 0, then we add 10, then 20, then 30, then 40, then 50. That's exactly the same number at the end of the day as starting with 10, 20, 30, 40, 50. But if we instead pass in a number like 1,000 here, our sum will start at 1,000, then add 10, then 20, then 30, and we end up with 1,150. So you probably wouldn't do this right here specifically, where you want the sum and you want to start at 1,000. But there are other use cases, which we'll see in the next video, where you can specify an initial value, and it won't even be a number. We'll see that we can specify an object if we're trying to accumulate data into an object, and that's what we're going to see next up. So to wrap this up, we saw that you can use reduce not just to multiply or to sum things together, but also to keep track of the max or the min or some piece of data. It doesn't have to be max or min. It could be the longest string in an array, the highest rated book, whatever it is. As we iterate over each element in an array, we are keeping track of some piece of data. And then the second thing we saw is that we can pass in an initial value as the second argument to reduce. So this whole thing is the first argument right before that comma, and then the second argument is right there. All right, we're almost done. We've got some other cool use cases coming up next. In our final video on reduce, yes, we've almost made it to the end here. We're going to see a completely different way of using it, where we can tally up results from an array. We can group different values in an array using an object. So here's a simple example. I have an array of votes, which I'm storing as y and n. It could also just be true and false. It could be yay and nay. We could have multiple votes. We could have yes, no, and abstain. We could have ratings. But what we're going to do is use reduce to produce an object where we have y, and we count the number of y's, like 12. And then the number of no's, like 8. Now, I don't think that's accurate for this exact array, but this is what we're going for. So what we're going to do is a little different. Our accumulator, the thing that will actually return and add into or update, is going to be an object. So we're going to have votes.reduce. We'll have some function. I'll just call it func for now. And our initial value will be an empty object. So I'll call this const results maybe. equals votes.reduce, our function which we have yet to fill out, and the initial value is an empty object. Remember, we specify an initial value, like 100. Accumulator, the first parameter to our reduce callback, starts at 100. In this case, we're using an object, so a little bit different, but the same idea. The initial value will be this empty object. Okay, so I'll draw it out down here. Then we're going to write our callback. I'll use an arrow function. The first piece is the accumulator. This is the piece of, you can think of it as like a memory from last time, from the last iteration of reduce. I'm going to call this one tally because that's what it represents. It's not really a sum or a total. Total would be okay, but tally it makes sense here. And then we'll have current item or current vote, or let's just call it val. All right, then an arrow function. And what we want to do here is add to this object using whatever key we have. So let's say it's y. We want to check, is there a y in this object? Because the very first time we encounter y, there won't be a key for y, it's just empty. So if we encounter y, we'll want to say y is 1. Then the next time through, we're not going to set y to 1, we're going to check, is there a y already? Yes, that was the first time through. So add 1 to it. Then we'll get to n, and we'll check, is there an n in this object? No, there's not, so set it equal to 1. So we'll have y2, n, 1. And then next time we get to an n, we'll increment it. So our logic will look something like this. If tally of val, meaning if we already have that key in the object, we're going to want to increment it. So tally of val plus plus. That means there's already something in there. So not this case. The very first time through, this code does not run because there is no value in tally. There is no yes, there's no no. So otherwise, that's the if part. I'll do this some more verbose way first. So we'll do tally val plus equals if it's already in there. If it's not in there, we'll write tally of val equals 1. We'll set it to 1, and then at the end, we'll return tally. Okay, so tally starts the very first time through, it's an empty object. Our val is y, the first element. Is there tally of val? No, it doesn't exist. This does not run here, but this does. So we set tally of val to be 1, and we return that. So the next time through, we have y 1. So now tally is equal to this object. That's what we're returning. Just like we did when we summed things together or when we found the max or the min, same pattern. We're just changing tally in a different way. We're not accumulating in the same format, but we are persisting this. We're returning it, and then next time through, that return value is used as tally. So we get to another y. y1, this is our object. If tally of val, well, there is y in this object. So that means we're going to increment it to be 2. Y of 2, and you can see where I'm going with this. We'll eventually hit n. There's not an n in here, so this part here does not run, and we instead set tally of n equal to 1. And then we keep going. So let's see what we end up with. We'll run this. What do we get when we call results? It looks like 7 yeses and 6 nos. I guess we can count that. I'll count the y's. 1, 2, 3, 4, 5, 6, 7. And the nos, 1, 2, 3, 4, 5, 6. Great. So if we had instead added some other types of votes in here, like, I don't know, NA, or how about absent? Let's just leave it like that. We'll run it again. Results. Now we have yeses 7, absent 1, N, nos 6. Now there is a shorter way of writing this, the logic itself that we have here, and I'll show that to you right now. Instead of doing this if and else, where we're checking if tally of val exists, and if it does, we'll add 1. If it doesn't, we'll initialize it to 1. We can rewrite this slightly differently. We'll say tally of val equals, and bear with me for a second, tally of val or 0 plus 1. Okay, so how does this one line work? Well, it all hinges upon this right here. Tally of val or 0. So if our object is empty at the beginning, there is no y, there's no n, we don't have any keys. The very first time we encounter y, for example, we're going to set tally of y to equal the current tally of y, which doesn't exist. So that gives us undefined or 0, which results in 0. So we're doing 0 plus 1, which is going to set it to 1. But the next time through, if we encounter y again, the very next element is y, we'll set tally of y equal to tally of y, which right now is 1. So then this becomes 1. 1 or 0 gives us 1. So then we end up with 1 plus 1, which is 2. So it's kind of a sneaky way of doing what we're doing up here. If something exists, add 1 to it. If it doesn't exist, set it to 1. We're just doing it in one line, taking advantage of this Boolean logic. So I need to reset that to tally of val, run this code again, results, it still works. So just a shorter way of writing it. Okay, so this is equivalent to this. We get the same result. One more example of using reduce. I have the same books array we've been working with. I added in a new book. Where are you? A truly horrible book. I wanted to give one a bad rating, but I didn't want to call out a real book and give it a bad rating. So this is a truly horrible book written by Save Your Time. Save your time, huh? Get it? Save your time. Very funny. So what I want to do is group all of these books in a new object, and I want to group them by rating. So all books that have a 2-star review will go, it will be an array. Then we'll have all books that have a 3-star, so 3 point something, not just exactly 3, but 3.67 and 3.83. And then all the 4-star books will go into the key of 4. So I'm going to use reduce for this, books.reduce, and we're going to add our accumulator function here. Just put gibberish, and we'll set the initial value to be an object as well, just like we did up here. We initialize it right there, or we give it an initial value. Okay, so our function is going to look like this. We'll have our accumulator parameter first. I'll call this grouped books, and then after that, we'll have each book. Arrow function. Then we need to get the rating from the book. So book.rating. But I want to eliminate the decimal. I don't want to use this as the key because that's far too unique. I only want 3. So I'm going to do a math.floor. Math.floor will just chop the decimal point off. Right? Math.floor of 5.4 gives us 5. 5.9 still gives us 5. So it's not rounding, it's just chopping off the decimal. So I'm going to save that to a variable. We'll call this key. Key equals that rating. So this will give us 2, 3, or 4 off the current data set at least. And then we want to check, does grouped books of key, does that exist? If not, we're going to make it an empty array. So I'd probably just do this. If not grouped books of that key, meaning there is currently no book with rating of 3 or rating of 4 or whatever rating we're working with, then I'll set grouped books of that key to be an empty array. Because remember, our goal here is to create an object where we have 3, which is an array of books. So each one of these would be a book with a rating of 3 point something. So if key is 4, if there is no grouped books of 4, it's empty. Then we're going to say grouped books of 4 is equal to an empty array. But then we also want to push in, so that will be grouped books of key dot push the entire book. So let me make this a bit bigger. And then finally, we'll return our grouped books. Okay, so this one's a bit longer. You could definitely shorten it up again, but just to summarize how it works, we have an empty object at the beginning. We encounter our first book, which is all the way up here. It has a rating of 4.25. So we get that rating, we chop the decimal off. Now key is 4. We're going to check, is there a key of 4 in grouped books? There's not, it's an empty object. So we're going to set it equal to an empty array. So we end up with 4 empty array. Then we say grouped books of 4.push the entire book. So that's when we add the whole book into that array. And then the process starts again, this time for 3. And let's say we get to another 4-star book like this one. We're going to get the key, which will be 4, chop the decimal off, we have 4. This part is false because grouped books of that key does exist now. So we only push. We don't do this, we don't set it to an empty array, we only push in a new book. So now we have 2 books in there. Let's make sure it works. Save it to a variable. Const grouped by ratings. It's kind of a long variable. Let's see. Grouped by ratings. We have our 2-star book, just this one book, a truly horrible book. We have 2 3-star books, and then we have our 4-star books. So this was a little bit more complicated, definitely. This is why I saved these examples for the very end, after we got maybe a little comfortable with reduce. If you're at all struggling with this, I don't blame you. This is a weird one, and why I kind of said I was scared to teach it, and why I always worry a bit about teaching reduce. It's hard to teach because there's so many uses for it. It's not as straightforward as the other built-in array callback methods. But don't feel bad if you are struggling with it. You'll get more practice. It will come more naturally with time, hopefully. It always trips beginners up. Okay, so that's reduce. Lots of different ways of using it, but it boils down to, pun intended, this diagram here, where we take multiple elements from an array and we turn them into one result somehow. Whether it's a sum, a product, or a min, a max, or we're tallying them into an object, or we're grouping them by rating or by genre or whatever, we end up with one result at the end. Multiple values into one value. That's reduce. We made it, and we're done with this section. Congratulations. This is a very meaty section.